We were looking at very specific types of functions in 8.3, and they were reciprocal functions. Now what we're going to do is look at any type of fractional function that has variables in it. On page 1255, there's a box. Yeah, go ahead and screenshot that. Put it in your notes. I'm going to go through it a little piece at a time. Obviously, when you screenshot it, you'll have the whole thing. But there's a ton of information in that box. And it's too much to look at it as a whole. It's better to look at it in pieces. So that's how we're going to proceed. So here's what we've got going on. In the reciprocal function, it had to be a very specific form. 1 or a constant over a linear function. Okay? And a rational function, meaning it's just a fraction with a bunch of variables, is not restricted that way. It can be really anything. Okay? So in this case, f of x, whatever our function is going to be some polynomial divided by some other polynomial. Okay, no common factors, meaning it's already been reduced. All the canceling's already been done. Okay. Of course, they have 1 in common. And the denominator cannot be 0. Why can the denominator not be 0? It makes it what? Undefined. Thank you. Okay, that's what makes things undefined, if the denominator equals 0. That we can't have. Okay, so we have a bunch of different cases here to kind of look at. And the rational functions, the vertical asymptotes, the idea behind vertical asymptotes doesn't change for rational functions. Horizontal asymptotes do. That's where we're going to see the big changes. Okay, so the first thing that we got to add to the list is, again, the vertical asymptotes don't change. Whatever makes the denominator 0, whatever makes the function undefined, that's where the vertical asymptotes are going to be. That is not new. All right. But here we get into some new stuff. All right. F of x will have at most 1 horizontal asymptote, which is the same, right? When we looked at reciprocal functions, there was only ever 1 horizontal asymptote. However, instead of just looking sort of to the outside of the fraction to see where the horizontal asymptote is, we have to look at the specific cases depending on what a of x is, whatever the numerator is, whatever the denominator is. And those cases have subcases. So, if the degree of a of x, the top, is bigger than the degree of the bottom. Okay, we've talked about degree. That's just the highest power on the variable. If the degree of the top is bigger than the degree of the bottom, there is not going to be a horizontal asymptote. And when you go to do your homework, you're going to state that. Because we're still going to identify the asymptotes like we have been doing. But when it gets to a situation like this, you're just going to say no horizontal asymptote. The degree on the top is bigger than the degree on the bottom. Okay, that's the first piece. The second part, if the degree on the bottom is, or degree on the top is less, meaning the degree on the bottom is bigger, then there is a horizontal asymptote, and it is at the line y equals 0. Or it could be, right, it could be f of x or g of x equals 0. It depends on the problem. But basically what we're saying here is the x-axis will be the horizontal asymptote, because that is the equation of the x-axis. Okay. That's the second case. First case, degree on the top's bigger. Second case, degree on the bottom's bigger. So what's the last possible case that we could have? The degrees are the same. Okay, so here's where it's tricky. Okay, if the degrees are the same, then what you do is you look at the leading coefficient for the top and you divide it by the leading coefficient of the bottom, and that will be your asymptote. All right. So if it was 3x squared on top and 2x squared on the bottom, and those were the leading coefficients, my asymptote would be y equals 3 over 2. Okay. So that's the case you kind of have to look out for, when the degrees are the same. Because then you have a little bit of division to do. It's nothing horrible. It's coefficients. It'll be pretty simple. Those are the three cases with the horizontal asymptotes that you have to pay attention to. Honestly, the rest of this section is what you've been doing. You go to your graph, you find some points, you draw your asymptotes in, you identify them, you state the domain and range when it asks for it, graph your graphs. Okay? All right. So on that same page, there are three graphs below that box, or maybe they're inside of that box. I don't know. But I'm going to go through them at a time. Okay, so if you want to add them, if you didn't add them, you can add them. Okay. So in this first example, I have f of x equals x squared over x plus 1. Okay, let's identify the vertical asymptotes. They're easy. All right, what is the vertical asymptote for this example? Be more specific. X equals negative 1. It's got to be an equation, right? It's a vertical line. So my vertical asymptote is x equals negative 1. So that idea of what we've been doing with 8.3 doesn't change. It's exactly the same. Right? In order to determine the horizontal asymptote, we have to look at the degree. What is the degree of the top? 2. What is the degree of the bottom? Which one's bigger? Top. So what does that mean? No horizontal asymptote. So we're going to write that in. No horizontal asymptote. That way I know you just didn't skip that part over. Okay? All right. Then we have our next graph. Now, obviously, they've drawn the asymptotes in already, but what are the vertical asymptotes here? X equals 1, x equals negative 1. Well, in reality, what we should do is probably factor this, right? X plus 1, x minus 1. So that's where we intuitively see, oh, it's x equals 1, x equals negative 1. Okay? Which degree is bigger, the top or the bottom? Bottom. What is the degree of the top? 0. There's no variable at all. 0. What's the degree of the bottom? 2. The degree of the bottom is 2. So the bottom's bigger, so that means the horizontal asymptote is what? Y equals 0, or in this case, f of x equals 0. Okay. Right. Since the problem has an f of x in it, we should write it as f of x. So we've done the degree on the top bigger, the degree on the bottom bigger. Now we got to do one where they're the same. Okay? So the degree on the top here is 1. The degree on the bottom here is 1. What's the vertical asymptote here?
3.
X equals 3. Okay? And then since the degree on the top is 1, the degree on the bottom is 1, what you do is you just basically look at 2x over x. Okay, so to figure out the horizontal asymptote, we're going to go f of x equals 2x over x, which is what? 2. Okay. And you notice on our graph, that's where it is, right? I already drew it in. This graph is going by 2's. All right, so that's f of x equals 2. And so that is my horizontal asymptote. So that's really the only change in terms of the horizontal asymptote. Now, to graph this stuff, okay, we're going to go through a whole problem of graphing because obviously on these three, you're already given the graph. All right, let's go through how to actually graph one when you're given an equation. Any questions before we do that? All right. So here's an example of a problem. Okay. Graph f of x equals x cubed over x minus 1. Right? It's a polynomial on top, polynomial on the bottom. So this falls under that category. Now, the same kinds of things are going to be in play like they were before. Okay? Where we have to identify the asymptotes, we have to draw them, I don't think we're going to do too much with domain and range in this section, though. Let me double check that before I get too far ahead of myself. Yeah, that is correct. Primarily, the domain's easy because of the vertical asymptotes like we did before. We get into a little more, it gets a little more tricky with the range because of the fact that there may or may not be an asymptote. So we're really not too concerned about domain and range in this section. Okay. Now, ultimately, what you're going to do is you're going to go to your calculator, you're going to put it in, and you're going to find some points. All right. The difference being here is that for every one vertical asymptote, there will be an extra curve. So like the ones we were doing with the reciprocal functions, we'd have one vertical asymptote and there would be two curves. In some of these problems, you might have two vertical asymptotes, which means there's going to be three curves. Or if there's three vertical asymptotes, there's going to be four curves. So in all of those situations, I want at least 3 points per curve. Now, some of the curves get kind of funky, and they take weird turns. So write down or find more points to make sure that your graph is as accurate as possible. Okay. One of the things the book does, and I'll do it here, but I just kind of like the idea of this. It's not necessarily something you have to do, but it is a good, easy point to kind of start with. Okay. So this first step, find the zeros because they're easy to find, right? So there's nothing actually that special about them besides the fact that they're zeros. They'd be solutions to the system, but that's not, or they're not the system, the equation. But that's not the point of what we're trying to do here. Okay. In order to be a zero, that fraction has to equal 0. So how is this thing equal to 0? What has to be true for this to be equal to 0? For a fraction to be equal to 0, what has to be true, generally speaking? Nope, that would be undefined. Numerator has to be equal to 0. Okay, so really what we have to do in order to find the zeros is solve this equation. X to the third equals 0. Again, it's just an easy point to find because whenever we have a fraction, if you set the top equal to 0, so long as it doesn't also make the bottom equal to 0, right? Bless you. If it makes the bottom also equal to 0, then we have a whole different problem because now it's undefined too. So that's bad, which means it'll have no zeros. Right? But in this case, that doesn't happen, as we'll see here in a second. So how do I solve this? X to the third equals 0. Cube root. What is the cube root of 0? Okay. So my 0 is x equals 0, which means I have a point at 0, 0. That's all it's telling me. Okay. Now, does it make the denominator equal to 0? No, it's -1, so we're fine. Okay. So that's just 1 point. Now we've got to deal with the asymptote. Okay, that's going to be our next step after that. So I want you to try to do that right now. Vertical asymptote, the equation for it, and the horizontal asymptote, equation for that. Let's start with the vertical asymptote. What is that? What's the equation for the vertical asymptote? X equals 1. 1 will make the denominator undefined. Okay, so I have one vertical asymptote, which means how many curves will there be on my graph? 2. There will be 2, one on each side of that asymptote. Okay. All right, horizontal asymptote. We got to look at. All right, for that we got to figure out what's going on with the degree. Degree is bigger where? On the top or the bottom? Okay, so what happens then? There is none. No horizontal asymptote. You can write it like that too if you want. You can do H dot A if you want to do that too. Or you could say no horizontal asymptote. I don't care. Any of those things are the same. It all works.
How do you find the horizontal asymptote?
So in the box on at the top of your notes, there's those 3 things there. Degree on the top is bigger, there's none. Degree on the bottom is bigger, there's y equals 0. And then if they're the same, divide the coefficient. All right. And then we just have to plot it, get our points. All right. Now, if you haven't already entered that into your calculator, I recommend that you do that because you're going to write some points down. And in this section, that's where you're probably really going to be manipulating the x values. In 8.3, I sort of showed you how to change the x's so they didn't just go by ones. Okay. If you notice, since I'm going to need, actually, if you haven't looked at the graph after you enter it in, I would do that if I were you. That would be the first thing. After you enter it in, I would actually look at the graph. Okay? Because if you look at the graph, you get a sense of how normalish looking it is or how funky looking it is. Okay? And hopefully what you see in this one is that's kind of funky looking. Right? At least different than what we've seen in the past. The other thing that you got to keep in mind, and this is why I talked about how many curves there should be, right? If there's one vertical asymptote and you only see one curve on your window, you're going to have to zoom out, zoom in, zoom right, something, okay? Because that vertical asymptote tells you how many curves there should be. And sometimes what will happen is there's part of a curve that's up real high above where y equals 10 or below where y equals negative 10, and you're going to have to keep searching for it. And so you're going to have to play with the window size in order to see the entire graph. Now in this case, that doesn't happen. We can see both curves, okay? And I went ahead and I changed my x values to go by 0.5s. And just, again, expect to have points that aren't always so pretty, right? If you look at those y values, there's really only 2 up there that don't have a decimal. Okay, 0, 0, which we already found, and then 2, 8. Okay. Again, I only need 3 points. The thing that you'll find interesting here is as I'm looking at these values, right, to the left of the curve, there's not a lot of spacing in my y's. These points are pretty close together. Okay, so you'll see what I'm about to do in a minute. Down here, it's a little bit better, but I'll explain why I still think there aren't enough points here. All right. And this is something that you're going to have to play with as you work through these problems. All right. Now, the first thing I like to do when we graph is graph some good points and put an asymptote in there. I like to put the asymptote in there first. Now, if you notice here, I added some points on the bottom to my table. And let me explain why. Okay, if I would have only used these points here to the right of the asymptote, I would have only gotten points going up. So I found this other point so that, because when you look at the graph, you see it kind of makes another turn back up and it approaches that asymptote. So I'm like, I got to get in between 1.5 and the asymptote. I got to get in there somewhere, right? Because I need a point in here. Because otherwise, they just look like they go up. And we look at the graph, and you can see that it turns back around. So that's why I went to 1.25 to see that, oh yeah, there's a good place for a point right there. Now the same thing was true with this side. These points were all real tucked in close here. And we see on the graph that it takes off over here. So that's why I went ahead and found where -3 was. Now, -3 was a matter of scrolling, right? I could just arrow up and -3 would have shown up on my table. The 1.25, I had to change my my table settings to go by 0.25s instead, all right? And so notice here, I have 3 points over here, great. But over here I have 1, 2, 3, 4, 5, 6, because I really want to get an accurate shape of the curve. So each problem will depend, right? When the funkier looking the curve, probably the more points you're going to need. Because I don't want just a crappy sketch. I would like you to make as accurate as possible of a graph. And so make sure your graph paper is turned on. That'll make this a lot easier to do. Sometimes you're going to want to change your scale and go by 2s or 5s or something, all right? But this is where it's kind of open-ended-ish. There's not just this right way to do it. Okay? But I want you to try to be as accurate as possibly can. And then, of course, it's a matter of connecting the dots and making as good a graph as you can. And that was probably try 3 or 4 for me until I got it. Okay? Questions? Yeah.
So for that like longer like line, there's kind of like close to curves in it.
Yep.
Like, is that considered 2 different, or is that just one?
No, since it's one, it's continuous, so there's never a gap in it, so it's all just one.
Okay.
Okay, so this, right. And so, that's a good question. Since there's one asymptote, I have this curve over here, and then I have this curve over here. But yeah, it's a funky curve. And that's going to happen. That's going to happen a lot more in 8.4 than you've ever seen before. Like, you maybe have seen them before, but you've never graphed them before. You've never had to come up with the points with them before. This is pretty new. Okay. And, to be fair, as you continue to move through your math life, and the courses get a little more tougher and the concepts get a little more abstract, this is going to happen more and more and more. Okay? And eventually, when you get to pre-calc and you start graphing trig functions and things like that, that's when they'll really start to get different than what you're used to.